This is the semester review. We're going to start with number 1, and I'm going to explain it step by step how to solve this absolute value inequality. Remember that absolute value inequalities have two solutions. So you have 2x minus 5 is less than or equal to 3, and 2x minus 5 is greater than or equal to negative 3. So that's the whole, what you have to remember on the test is that for absolute value, there's two possible answers. One of them is less than or equal to 3, and the other one is greater than or equal to negative 3, and then you just solve it like normally would, solve like you solve an equation. So you add 5 to both sides. So you have 2x is less than or equal to 8. And so you have x is less than or equal to 4, because you have to divide 8 by 4. Then you add 5 to both sides. So you have 2x is greater than or equal to 2. So x is greater than or equal to 2. So what you have to do, on the number line you go to 4, make a circle, go to 2. Now since it's equal, it's going to be shaded. And the first one says x is less than or equal to 4, so it's going to go to the left. And the other one says x is greater than or equal to 2, so it's going to go to the right. And you notice that both lines intersect. Well, that's going to be the answer. The answer is going to be all the numbers between 2 and 4. So x is less than or equal to 4, and x is greater than or equal to 2. And so on the test, you would have to make sure that you indicate that those are all the solutions. Okay, so what we're going to do here is we're going to graph the solution for the absolute value of x minus 4 is less than 3. So you have x minus 4 is less than 3, and x minus 4 is greater than negative 3. So you add 4 to both sides. Remember to add 4 to both sides since you're solving the inequality for x. So x is less than 7. The other one, you have to add 4 to both sides. So we have x is greater than 1. So go to 7 and go to 1. And we know that it says x is less than 7. And we know that x is greater than 1. And you notice that the two intersect. Now, in this answer, we don't include 1 and 7 since there isn't equals. So remember that it will be all the answers between all the numbers between 1 and 7, not including 1 or 7. And what you need to remember is that since there isn't an equal sign, it's going to be an open circle. Given f of x, which statement best describes the transformations applied to the parent function? So this is an absolute value x. What you have to do is describe what's going to happen in the transformation. So if you have a negative here, it's going to reflect over the x-axis. The minus 5, it's going to shift the equation down, the graph down, 5 units. And that plus 3, remember, this is the only one that you have to remember, that if it's plus 3, it's not going to go to the right, it's going to go to the opposite, it's going to shift left. So if you want to check this, you're going to go ahead and graph this, and I'm going to go ahead and do that. Okay, as you can see, I graphed both equations. Here is the absolute value equation, and here is the transformation. So the negative reflects over the x, the minus 5 shifts it down, and the plus 3 moves it left. Given f of x, what effect do the constants have on the absolute value function? So you see the 1/4? Well, it says what effect do the constants, okay, I guess you can say like these numbers, what effects do they have? Well, the 1/4 is going to actually make it wider. The minus 2 is going to shift it to the right. You would think it'd go to the left, but it goes to the right, and then the plus 1 shifts it up. As I said before, the parent function is wider. Now the blue is the parent function. This is the new function here. So the 1/4 makes it wider. The minus 2 shifts it to the right, and the plus 1 shifts it up. So for question 5, you have to find the inverse. But first, what I would do is I would apply the distributive property. 5/7 times 14 is going to be 14 divided by 7 is 2. 5 times 2 is 10, so it's 10x. 5/7 times 21. 21 divided by 7 is 3, so 5 times 3 is 15. Now to find the inverse, remember that you're going to rewrite it as y equals 10x plus 15. And to find the inverse, you have to switch the x and the y variable. So you have x is equal to 10y plus 15. Then you have to solve for y, so you subtract 15 from both sides. So you have 10y equals x minus 15. Then divide by 10. So you have y equals x over 10 minus, and you notice that 15 divided by 10 can be simplified. The common factor is 5, so it's 3 over 2. Now, you have to write it as in this form. So the inverse of f is equal to x over 10 minus 3 over 2. Given f of x and g of x, verify f of x and g of x are inverse. You have to find the composition of both functions to check if they're inverse. And remember that it has to come out to x. If it fails to come out to x, then you can automatically stop and say they're not inverse of each other. So I'm going to do g of f of x. So we have g, f of x is 5x plus 7 equals, remember that g is x squared, so you have 5x plus 7 squared minus 7. So what happens is f of x goes into function g. And now you're going to have to multiply 5x plus 7 times 5x plus 7 minus 7. So 5x times 5x gives you 25x squared. 5x times 7 gives you 35x plus 35x. And then you have 7 times 7, which is 49 minus 7, and obviously this is not going to come out to x. So we can stop at this point. They are not inverse of each other. So yeah, you have to do the composition. Remember that f of x goes into g of x, and that's how you check if they're both inverse of each other. Once again, you have f of x and g of x are inverse of each other. And what you want to do is you want to check if the composition of f of g of x is equal to x and g of f of x is equal to x. That's the only way you can check if they're inverse of each other. Now you can also graph it, and remember the relationship, you have to have it graphically, they have to be reflection over y equals x. That's another way you can check. And you can also look at their tables. If their x and y values switch, then you know that they're both inverse of each other. So we have f of x minus 2 divided by 3. So you have 3 times x minus 2 divided by 3, and then it's going to be plus 2, right? Now you notice that when I do this, 3 divided by 3 is going to cancel. That's going to be 1. So you have x minus 2 plus 2. So what happens when you have negative 2 plus 2? That's going to be 0. So f of g of x, that works. It's going to be x. So now you have to test g of f of x. So it's going to be g, and then you have 3x plus 2 equals g. So you have 3x plus 2 minus 2 divided by 3. You have 2 minus 2, that's 0. 3 divided by 3 is 1, so you're left with x. So g of f of x is equal to x, so that checks. So what conclusion can you make? They're both going to be inverse of each other, and you can check by looking at the calculator. It says solve the quadratic equation by completing the square. Now, I didn't teach you completing the square, but I have taught you how to solve a quadratic. You can solve this many ways. You can solve it by factoring. You can solve it by the quadratic formula. In this one, I'm going to solve it by factoring. So I'm going to look at the factors of 5. So the factors of 5, 1 and 5, negative 1 and negative 5. So the ones that we're going to use are negative 1 plus negative 5, that gives negative 6. So the factors are x minus 1 times x minus 5 is equal to 0. So you set each of them equal to 0. X minus 1 equals 0. X minus 5 equals 0. So the first answer is x equal 1, and the second answer is x equal 5. Now, what you need to know is that these are called zeros, x-intercepts, roots, and they're also called solutions. Now, if you want to check it, you can actually go to the graph and you have x squared, right? And you want to find the zeros, so all you have to do is go to the 0, and so the first 0 is 5, which we said was 5. And then the second 0 is 1, so that's what we had. So it says solve the quadratic equation by completing the square. Now, I didn't teach you completing the square, but I did teach you how to solve the quadratic. I'm going to solve this by using the quadratic formula. So the quadratic formula is x equals negative b plus or minus square root b squared minus 4 times a times c divided by 2 times a. So I need to identify a. A is 1, b is 4, c is 8. And then what I'm going to do is I'm going to go ahead and substitute. So I have x equals, the value of b is 4, so it's going to be negative 4, plus or minus square root. This is the discriminant. And then you have 2 times a, which is going to be 2 times 1, so it's 2. So it's negative 4 plus or minus square root. And so I'm going to go to the calculator to evaluate the discriminant. So I have parentheses. Always remember your parentheses. Even though it's positive, just get in the habit of doing that. 4 squared minus 4 times 1 times 8. So you have negative 16. And then what you have to do is you have to divide this whole thing, you have to divide it by 2. Now remember, we've been talking recently about complex numbers. So this is an imaginary number, there's a complex number. So the square root of 16 is 4. So that's going to be 4i. So you have negative 4 plus or minus 4i divided by 2. So the answer is bundled. So you have negative 2 plus or minus 4 divided by 2 is 2i. What is the factored form of the expression? So we have 3x squared plus 9x plus 6. So what you have to do first is identify, is there any number that's in common? That's what you call the greatest common factor. So you got to find the greatest common factor, and of course 3 is the greatest common factor. So you have x squared plus 3x plus 2. Then you have to look at 2 and identify 2 numbers that you can multiply to give you 2 but add to give you 3. So you have to find the factors of 2. So you have 1 and 2. You have negative 1 and negative 2. And you start adding. So it is 1 and 2. So you have 3 parentheses x plus 1 and x plus 2. What is the factored form of the expression 5x squared minus 20x plus 15? So you first have to look for the greatest common factor. So what number goes into 5, what number goes into 20, what number goes into 15? So you know that 5 is the greatest common factor, so you have x squared minus 20x, minus 4x plus 3. So the greatest common factor is 5, and so you have 5 times x squared gives you 5x squared. 5 times negative 4 gives you negative 20x, and then 5 times 3 gives you 15. We're going to go ahead and factor by looking at the 3. So what 2 numbers do you multiply to get 3? So you have 3 and 1. You have negative 3 and negative 1. And you start adding. 3 plus 1 gives you 4. Negative 3 plus negative 1 gives you negative 4. So you have 5 parentheses x minus 3 and x minus 1. Remember that we do have a quadratic. This right here is the focus. And this right here is the directrix. The equation is y equals 1 over 4 c times x squared, where c is the focus. So for question 12, it says, what are the focus and the directrix of the parabola with the equation y equals 1 over 8 parentheses x plus 4 squared minus 2. Okay, so what I'm going to do is I'm going to try to find the focus and the center. So this right here is your a value. So a equals 1 over 4c. So 1 over 4c equals 1 over 8. So you notice that c has to be 2. So I'm going to come over here and I'm going to graph the focus. 0, 2. That's the focus. Now the directrix is going to be y equals -2. Y So you notice that this parabola has to open up. So what I'm going to do is I'm going to graph it. Y equals 1 over 8 parentheses x plus 4 squared minus 2. Okay. So my focus should have been over here, and it should have been, I guess I have to shift 4 units to the left, and I have to go down 2. So my focus, I have to go over 4 units to the left. So right now it's at 0, 2, so it has to go to -4. It has to go to -4. No, I take that back. It has to go. So it has to go 4 units to the left. So that's the new focus. Now we got a problem with the directrix. So what I have to do with the directrix, I have to shift this down another 2 units. And there it is. So my new focus is at -4, 2, and my directrix is at, so the focus is at, and let me label it. Okay, well, it's -4, 2, and the directrix, it's not at y equals -2, it's at y equals -5. Number 14, what are the focus and the directrix of the parabola? Remember that I taught you this is the parabola, this is the focus, this is the directrix, and we know that they're equidistant to the parabola. And I know that you can find the focus by using this value, 1 over -120, that's 1 over 4c. So 1 over 4c is equal to -1 over 20. So you know that c, which is your focus, has to equal -5. Why? Because 4 times -5 gives you 20. So this right here is your focus. And so what I'm going to do is I'm going to graph the focus so you can see the picture in Desmos. So we have our focus, which is 0, -5. That's your focus. Okay, so now we need the directrix. So the directrix is that horizontal line that is equidistant to the parabola. So you notice that here's the focus, so the parabola is going to have to open down. And so the directrix is at y equals 5. But if you graph this equation, you notice that there has been a transformation, right? So we have y equals -1 over 20, parentheses x minus 5 squared plus 10. Okay, so what happened is the transformation is it went 5 to the right and 10 up. So I have to move the focus 5 units to the right. And then I gotta move it 10 units up. So how did I get here? Well, what I did is I went 5 units to the right and then 10 units up, and that's how I got to the focus. Well, the focus is at 5, now it has to be at 15. So we have y equals 15. So basically you have to add, or you have to adjust by applying the transformation. So the focus was at 0, it was at 0, -5. So I had to go 5 units. I had to go 5 units to the right and then 10 units up. So my new focus is at 5, 5. And the new directrix is at y equals 15. And it opens downward, and you can see that here. So basically you have to apply the transformation. The function h of x is a parabola that opens upward and a vertex of -3, -2. Now, just by me looking at the negatives here, these are going to open, they're going to open down. So automatically these are wrong. Now, one of these two is going to be correct. Since it's -2, it has to be shifted down. So that shifts it down here. This shifts it up. So the only answer has to be this first one here. So I'm going to show you. So we have g of x equals parentheses x plus 3 squared minus 2. So if I click on Desmos, there is a vertex -3, -2. It says, what is the range of the function displayed below? We notice that it reaches its highest point at y equals 7. So the range will be y is less than or equal to 7. That's in its inequality form. Interval form, it's going to be the lowest, which is -infinity, and the highest is +infinity, which is 7. So the range can be in both inequality or interval form. What is the range of the function displayed below? So the lowest value is 1. So it's in its inequality form. Its y is greater than or equal to 1. Since the lowest value is 1, it's going to go bracket 1. Bracket means that you include 1, comma, then of course infinity. We don't know what infinity is. Since it continues, it goes to infinity. And so it's going to be parentheses. What is the next step in the solution to this quadratic inequality? This quadratic equation? So what they want you to do is they want you to actually show the steps to solve this. So the first step, of course, is making sure this is equal to 0. The next step is to identify your A, B, and C. And then if you're using the quadratic formula, it's going to be B plus or minus square root B squared minus 4 times AC divided by 2A, and I think it's negative B. So X equals negative 20 plus or minus square root. So you have 20 squared minus 4 times 4 times 13 divided by 2 times 4. So that's the steps for the quadratic formula. So I'm going to go ahead and evaluate the discriminant. I'm going to use Desmos here. So I have parentheses 20 squared minus 4 times 4 times 13. So it's 192. So X equals, and I'm going to double check that. So you have 20 squared minus 4 times 4. Okay. Square root. So it's going to be negative 20 plus or minus square root of 192 divided by 2 times 4, which is 8. You might want to check if you can get the square root of 192. I would leave it like that. And then you probably want to simplify negative 20 over 8. So that's going to be 4. So it's negative 5 over 2 plus or minus square root of 192 over 8. What are the roots for 4x squared plus 13 minus 20x? So to solve this, you have to make sure it's going to be 4x squared plus 20x plus 13 equals 0. It has to be set equal to 0, the equation. So A equals 4, B equals 20, and C equals 13. And then you're going to use a quadratic formula. So you have X equals negative B, which is negative 20, plus or minus square root 20 squared minus 4 times A, which is 4, times C, which is 13, divided by 2 times A, which is 2 times 4. Evaluate the discriminant. It looks like it's like the same answer. It's 20 squared minus 4 times 4 times 3. Yeah, it's the same answer. So as the one before, X equals negative 20 plus or minus square root of 192 over, and it's all over 8. So it's the same answer as the one before it. Jason throws a ball from a height h and meters above the ground, t seconds after being thrown. Determine how many seconds it takes for the basketball to reach its highest maximum height. So I'm going to go ahead and use decimals. So we have h of t, and you can just write it like that in decimals. H of t equals negative 1/2 t squared plus 5t plus 2. And as you can see, decimals, you're able to label your axis. So x is going to represent time, and the y value is going to represent height in meters. And so if I click on this, it says at 5 seconds, it's going to be 14.5 meters. That's when it reaches its highest point. So it would be at 5 seconds, it would reach its highest point, which is 14.5 meters. 26 is a complex number and you're multiplying it. And so you have 5 times negative 10, which is negative 50. 5 times 6i, which is positive 30i. I times negative 10 is negative 10i. And what I'm doing here is called the FOIL method. I times 6i is going to be plus 6i squared. Remember that I squared is negative. So you have negative 50 plus 20i minus 6. So this will be negative 56 plus 20i. I do want to tell you that you can check this on the calculator. Parentheses 5 plus, go here to the pi, and then you're going to have I. And then parentheses negative 10 plus 6, and then go to this right here, I. And then press enter. And I think that's what we had, negative 56 plus 20i. 27, we're multiplying these complex numbers. So what you're going to do is you're going to apply the distributive property. 11 times negative 10, which is negative 110. 11 times negative 8, which is negative 8i. 5i times negative 10, which gives you negative 50i. 5i times negative 8 is going to be negative 40i squared, and I did make a mistake. 11 times negative 10 is negative 110. 11 times negative 8i is negative 88i minus 50i. Now this here is going to be I squared is negative 1, so it's positive 40. So negative 110 plus 40 is going to be negative 70. And this will be negative 138i. So once again, you can check parentheses 11 plus 5i, and then parentheses negative 10 minus 8 I, right? So i's over here. Enter, and there it is.